With the Agile Mover, we've gone in the direction as light and as fast as possible. We've shaved as much weight out of the mover as we can. The mover now has a mass of around 350 grams and can accept a payload of 150 or 200 grams. Combining that with a 100 Newton magnet, we're able to reach 20 G in acceleration. That means the mover can go from stopped to 4 meters per second in just 50 millimeters. That's the length of the mover itself. That's necessary for a lot of our high-speed applications, things where we want to use a sensor to detect a part and then catch that part. With a super high acceleration, I can put the sensor nearer to the mover. So now I can place a sensor 100 millimeters from where the mover is parked, detect that a part has come, and within 50 millimeters of the mover, I've now accelerated up, caught that part, and I can now process that part further. So everything now gets smaller. And I can do more things with this. Rather than using that 100 newtons just to get a nearly 1 kilogram mover around the system and using all the energy to push a mover and nearly none of the energy to push maybe a 10 or a 50 gram part. Now we go in the other direction where we're much more efficient. All of the force is going into moving the part rather than moving the tooling. We can also take it the other direction and say, okay, what can I do with rated current? Rather than just using the peaks, I want to continuously, in a section, apply a lot of acceleration. So now with rated current, I can get 6G acceleration out of a system. And now I can do a lot more things with higher part rates. It used to be that at 600 parts per minute, we were pushing the boundaries of what we could do with an XTS. Now we can double that. 1,200 parts per minute is relatively easy, and perhaps even faster, 1,500 parts per minute. It's all a question of really what do we do with these forces now? Now that I have much more rated current to be accelerating movers rather than trying to just simply accelerate a big piece of aluminum. The system has also gotten quieter. So here behind me I have a system running at full speed or nearly full speed. It's only running with 15G acceleration. And it's quiet enough that I can easily talk over it. So let's see what we can really do with this system and let's make it go full speed.
Well, brilliant, fantastic insight there, Rob. Incredible performance, and well done for actually managing to film it. It's eye-wateringly fast. They say dynamite comes in small packages. Tim, great job. And you know, when we're actually looking at the detail of the movers, you know, I can see that the standard mover I've got here, it's substantially larger than the Agile mover that you've got there. Talk me through some of the differences.
Well, the most obvious difference is the size of the bearings. They're much smaller. They're also more compact to the mover body itself, so there's less of a lever in the drive force. The body is lightened and again made more compact to give us the a bare mass of around 200 grams.
Okay, no, that's interesting. So, you know, for my understanding, you know, what does that actually mean in terms of how does it go faster?
Well, basically the lower mass allows us to accelerate much faster to top speed, but not just accelerate. It allows us to decelerate much faster as well. So your transit time from point to point is significantly less, allowing a far higher throughput.
No, that's very interesting. So essentially what you're talking about is if you had two cars in a race, you know, they both got the same top speed, but one, you know, is a Ferrari acceleration and slamming the brakes on, and the other one's a Focus or something. So yeah, I'm with you. Right, brilliant. In terms of the type of application we'd be looking at, you know, talk us through typical sort of uses.
Well, our target applications are very low mass. So we're looking payloads under 200 grams. We are looking at probably confectionery or bakery products, high volume, high throughput, relatively low value component cost, where we just need parts per minute. What we're looking for is parts per minute.
Oh, fantastic. Yeah, very interesting. Yeah, thank you, Tim.
Thank you.